Well, hello, how you going? I haven't played my guitar in a while, so I figured I would keep you up to date with what I'm doing with type closure while changing my guitar strings so I can get back into it. So, let's get my guitar up. See what it looks like. There's this. The E string is not where it's supposed to be. But anyway, if you've been following my Twitter feed, I recently finished my first paper submission to ICFP, which is the International Conference for Functional Programming, and I basically summarized the last how long has type closure been around? 3 years? 2.5 years? Yeah, it's coming up on 3 years. The last 3 years of development. So the major kind of features of this paper was describing H-maps, heterogeneous maps, Java interop, and what's the other thing? Multi-methods, and how they all kind of interact together in a way that's novel, from the perspective of that type closure is an extension of type racket, in some sense. So recently, I've been working towards the goal of making type closure gradually typed. So what does gradually typed actually mean? Well, so is type closure gradually typed already? Well, not really, no. At the moment, it's at best optionally typed. What have we got here? So, what does optionally typed mean? Well, it's not really a technical term in my opinion, but what I mean when I say optionally typed is that you can add type annotations if you want to get type checking, otherwise you won't get type checking. That's really all I mean. So what else could there be? Well, there's this concept called gradual typing, which you might, if you've seen me talk about at almost any event, I always seem to be talking about this, but it's finally time to implement this. And the idea is that you have typed and untyped lands, and the crucial part of gradual typing is this barrier in the middle that mediates communication between the two sides. Okay. So that's lovely. So what we want to do with type closure is to add this sort of barrier, this mediator that can protect the type side from all the scary things that can happen in untyped side. So for example, if we had a mutable structure like a vector defined in typed land and we pass it to untyped land, then say we only wanted positive like natural numbers to be written to this vector and we pass it to untyped land. Well, we want to make sure that untyped land doesn't write positive or negative naturals or null or anything like that to this vector. So this is the kind of problem that gradual typing will solve. And if you've ever programmed in type closure, you'll find that sometimes you'll have to redirect control flow or move functions around or compensate for changes that you made just to get things type checking. And you might accidentally change some untyped code, and then code that worked before now throws a null pointer exception just because of the subtle ways that you've changed it, and it throws a null pointer exception in your typed code. And this kind of goes against this this idea of gradual typing and blame. So when I talk about blame, that's kind of the source of an error. So think of it as an extra annotation, except other than a line number to an error. So when you get a runtime error, you get a line number, and in systems like Racket, you also get something called a blame label. So a blame label can be something like a module or a input or output of a function. So what we don't ever want to do is for an error to blame a typed module, because the theorem says that well-typed modules cannot be blamed. Or if you have something that's more typed and less typed, then the more typed thing, it should never be blamed. You should also always blame the less typed thing. So it's fairly easy to get code that blames typed Clojure for a runtime error. So this is basically what we want to address in gradually typed Clojure. So what are the hurdles? So there's some pretty interesting work going on in this field. Mike Vitusek, one of my colleagues at Indiana University, has been experimenting with a gradual typing system called reticulated Python, and I think he will be presenting it at some Python conferences coming up. So look out for some YouTube videos of that. But in his experimentations, he's been kind of trying out different semantics or different ways of modeling kind of the runtime contract checking mechanism. So for example, you could check this vector, remember this vector that we only wanted to write positive naturals to it, or natural numbers. You could protect that by every time it goes to untyped things, just wrap it up in a proxy that intercepts all set operations on this vector and makes sure that it's always an integer. So that's a semantic that he has experimented with called the guarded semantics. And there's another semantics. You can imagine that you could also simulate this by you could also make sure that, well, let's think about the problem. Do we really care if this vector is written, if it's written a number, if it's written nil, or do we care that when we try and get things out of the vector in the typed land that you only get out naturals? So in guarded semantics, we say, well, we do care. We have to, at every write, we must check this. But in transient semantics, it's kind of a different perspective. Well, it's like if a tree falls in the wood or in the forest, do we ever hear it fall? Well, if you never get this null out of a vector, was it ever there in the first place in the typed land? Well, transient semantics says no. So there's actually concretely, transient semantics rewrites the typed code to be defensive, and it always assumes that, for example, if you do a vector get of a particular kind of element of the vector, it casts it to integer or to a natural number implicitly. So why do we care about these multiple semantics? Well, one of the trade-offs is with the guarded semantics, which uses proxies. This has the well-known property that proxies break pointer equality. So if you had a program that tested this vector on pointer equality and went down one branch if it was pointer equal and went down another branch, well, if you've now wrapped this vector in a proxy, then your program's going to take a different path. So this actually violates a principle of gradual typing, which is formalized as the gradual guarantee, which will appear in a conference called Snapple in the near future. I'm not exactly sure when, but the gradual guarantee says that we can climb up and down the ladder of typedness. If we add annotations, we can be more typed. If we go down the ladder, we can be less typed. Sorry. So any code that crosses this language boundary from typed to untyped will only be able to call the transient version, kind of the safer version. This seems like it might work in practice because you might imagine type Clojure can compile it once, assuming it's transient, and compile it again, assuming that we have static semantics. But I think this breaks in a higher order context. So if we have higher order functions. So for example, if we have our uncontracted, really fast typed version here, and we have our transient typed version here and untyped version here, if we define an uncontracted higher order function and pass it to the transient version, and then the transient version, say, passes it to untyped, and then now the untyped thing, so say this is an increment function that takes a number, increments it. So, and this has no runtime contract on it, so it travels all the way to untyped. So imagine if we called this with null at untyped. So what will happen is we get an error that blames that we've tried to add 1 to nil, even though the error is from here. So it seems like if you want transient semantics, you can't split these two typed lands. You basically have to just generate these checks everywhere, no matter how redundant they are. So as far as I know, this is a similar approach to a paper I saw at Popple called Confined. It's either Confined Gradual Typing or Confined TypeScript, and it basically tracks whether you need to add extra runtime checks to TypeScript code to make it safe. So I need to go back and revisit that paper. Just make a bit of progress on this guitar. So, just a little more. So that's kind of what I've been up to. I've been learning some coq. If you haven't heard, that's a theorem proving. It's an automated. What do you call it? Proof assistant. Yeah, I've been learning a lot related to my programming languages theory class. We've been formalizing the simply typed lambda calculus, different versions that use type environments, others that use type substitutions, others that have mutable references. To be honest, I think I'm starting much further behind than some of my my classmates in terms of theorem proving. I'm pretty bad at theorem proving, even on paper. So yeah, it's been a struggle, but I'm finding coq very entertaining and a lot of fun. So yeah, that's something that I've been looking forward to this this semester. Pick an E. I like to stretch out some of my strings before I find if I stretch them out sufficiently, then they don't go out of tune. But you know, this is a pretty old guitar, so it doesn't always happen. But what else can I tell you? So I think the next few months we'll be figuring out gradual typing. I'll be thinking at some point about TypeScript, Clojure script, typed Clojure script, that is. So look forward to that. I think gradual typing in Clojure script might be a little more interesting than on the JVM, since we can do a lot more flexible things in ClojureScript with respect to proxying than in Java. So Google Summer of Code is also starting soon, so we've got to work through some of the proposals. I'm hoping to talk with some of my students before the proposal, before the mentors have to vote on the projects. Let's go. Like this string is sliding away somewhere. I would play you something, but it's just going out of tune. I'm not sure why. Maybe I didn't. I feel like it's slipping out of the, Well, mission accomplished. I have changed the string, so that'll make me more likely to actually play this thing. So yeah, thanks for watching, and I hope you enjoyed listening to my ramblings. Yeah, I'm really enjoying my work with type Clojure, and hopefully I'll keep you up to date with what I'm doing. And once I get this in tune, I might play you another tune. But yeah, thanks for sticking around. See ya. Is that A? That's what I'm thinking of.